All right, welcome back to these hopefully short little videos on how to do stoichiometry. This is video 2 in the series. This is talking about mole-to-mole stoichiometry, and we'll even do a little bit of mass-to-mole and mole-to-mass stoichiometry as well. In mole-to-mole stoichiometry, we are going from moles of one chemical in our balanced equation to moles of some other chemical in that equation. All right, the important thing here is we are in the mole. It's called mole to mole because the main unit of it is the mole. And every time we see this going forward here, I am going to draw this kind of conversion in red. And we're going to use that factor label method we learned way back in Unit 1. All right, and what we're doing is we're going to multiply our starting mole amount. So we're going to have a starting mole amount we're going to put it over 1, because you can put anything over 1, and then we're going to multiply that by the coefficient of the wanted chemical from the question and divide by the coefficient and formula of the given chemical in the question. We'll see how that works with a couple of examples here. So in this first example, we have 2.5 moles of oxygen gas. This is what we are given. So that's our starting amount, 2.5 moles of O2, which is the formula for oxygen gas. We're going to plop that over 1. So this, if 2.5 moles of oxygen gas reacts completely with hydrogen gas, how many moles of water are produced? How many is our key words. Those are our questioning words that tell us what we want. So at the end of all this, we want water. So what I'm going to do is I'm going to go in and I'm going to multiply this by the coefficient of the wanted chemical from the balanced equation right here. 2 H2Os over the coefficient of my given chemical, which was O2. There is no coefficient, so that means there's a little 1 hidden. Notice how my oxygens cancel out. And so I have 2.5 times 2 gives me 5.0 if I'm following sig figs, moles of H2O. Both my denominators are 0, so I don't have to worry about, or both my denominators are 1, so I don't have to worry about them, and I get my answer. All right, let's look at a couple other examples. All right, here we have formula of sodium carbonate plus calcium nitrate, giving us 2 sodium nitrates and a calcium carbonate. This is already balanced for us, so I just got to read the question, figure out what I want and what I'm given. Question 1 here starts off with how many moles of NaNO3? So NaNO3 here is what I want in this question. Are produced with 0.345 moles of CaCO3. So I am given CaCO3. All right, let's write down what we got here. My given amount is 0.345 moles of CaCO3 in parentheses. I'm going to put this over a 1. Multiply it by my mole ratio. All right, there's 1 CaCO3 in my balanced equation. Cross that out first. There are 2 NaNO3s in my balanced equation. 0.345 times 2 is 0.690. My units that have not canceled end up being moles of NaNO3. And both my denominators are 1, so I can ignore it. And there's my answer, 0.690 moles of NaNO3. All right, let's look at the next one. Next one, how many moles of CaNO3, calcium nitrate, will completely react with 12.5 moles of sodium carbonate, Na2CO3. All right, so in this one, I'm starting with 12.5 moles of Na2CO3 over 1. By my mole ratio, there's 1 Na2CO3 from the balanced equation, and there's 1 CaNO3 2. My sodium carbonates cancel. 12.5 times 1 divided by 1 divided by 1 gives me 12.5 moles of calcium nitrate. And there's my answer. Yes, the number is the same, which shouldn't be surprising if you see that the mole ratio is 1 to 1. All right? Mole-mole conversions are really pretty easy. It's a one-step conversion. You don't have to think too much about it. All right? Let's kick it up a notch. 5, 6. Let's look at mass mole stoichiometry. In mass mole stoichiometry, we got the mass of one chemical in a reaction, and we're converting it to moles of another chemical. All right, so in this case, we start with mass. All right, we are given a starting mass, something in grams. All right, and then we do two things. First thing we multiply by is a conversion that converts our mass to moles. We got to get into the mole before we can change our chemical around. 1 mole of the given chemical is equal to the formula mass of the given chemical. So we have to find formula mass, adding up everything in the formula. And then once we have moles, we can now multiply by that sweet, sweet mole ratio that we talked about earlier. Coefficient of what is wanted divided by the coefficient of what is given. And that will change our chemical for us and stoich it up. All right, so this example, we're given 25 grams of oxygen gas. All right, it's going to react completely with hydrogen, and I want to know how many moles of water. I'm starting with 25 grams of oxygen gas, which is O2. Put that over 1. My first step is to get those grams into moles. 1 mole for oxygen gas is equal to the formula mass of O2 in grams. Formula mass of O2 is oxygen plus oxygen. All right, I can find these masses on a periodic table. On my table, each oxygen is equal to 16.00. So I get 32.00 grams as the formula mass of oxygen. The second, and then that cancels out my unit of grams. I now have a unit of moles of oxygen. Now that I have moles, I can change that chemical up by using my balanced equation. There's 1 O2 for every 2 H2Os. Now my oxygens cancel. Multiply my numerators. 25 times 1 times 2 is 50. Carry the units over. Moles of H2O. There are no units in the denominator, but it's still 1 times 32 times 1, which is 32.00. Get out a handy dandy calculating device. 50 divided by 32 is 1.625 moles of water. I started with 2 sig figs and 25, so the 1 and the 5 are my 2 sig figs. The 6 tells me to round up. I get 1.6 moles of water as my answer. That is mole, or that is mass to mole. Start with a mass and in a mole. Very, very similar to mass to mole is mole to mass. It just means I'm starting somewhere different. Here, I'm going from moles of one chemical to mass of another chemical. All right. Again, in this case, I have a starting mole amount over 1. Since I'm starting in moles this time, my very first part of the conversion is using that mole ratio, the coefficients of what I want and what I've got. All right, here they are right here. All right, and then my second part is now I got to convert from moles into mass of my new chemical, my wanted chemical, And so to do that, I'm going to remember that the formula mass is equal to 1 mole, so I got to put the formula mass in grams over 1 mole. All right, and that's going to be my pinky purple step going forward. So let's look at the question. If we got 2.5 moles of hydrogen gas, there's my starting amount. .5 moles of H2. Pop it over a 1. Help me establish a numerator and denominator. I get this hydrogen gas to react completely with oxygen gas, and I want to know how many grams of water. So my first step is going to be to change out my hydrogens to waters. There are 2 H2s in my balanced equation, cancels out the H2s for every 2 H2Os. I could reduce both these 2's to 1's if I want to, but the math will all work out at the end, so I'm not going to. I don't want to try to do too much in my head and end up making a mental error. The second part is some number of grams of water is 1 mole. This number of grams is the formula mass of water. So water is 2 H's plus 1 O, 2 hydrogens and an oxygen. Using my periodic table, I take 2 times the mass of hydrogen, which is 1.008, giving me 2.016. 1 oxygen is 16.00. Adding them together, I get 18.016, which rounds to 18.02 to 2 decimals because sig figs. My formula mass of water is 18.02. This cancels out the unit of moles. So now it's math time. 2.5 times 2 times 18.02. This gives me 90.1 grams of H2O all over 2. 45.05 grams of H2O. I have 2 sig figs in 2.5. So the 4 and the 5 are my 2 sig figs. 0 tells me not to round. Keep my number the same, so I got 45 grams of water as my answer if I followed all my sig fig rules as well. Alright, and that's all there is to mole mass stoichiometry and mass mole stoichiometry. It's somewhere in there you need a formula mass and you have to convert to or from the mole as appropriate. If you have any questions, please contact whoever your teacher is. If it's me, you know where and when to find me. And have a good night.